Section 4. Understanding K-PaaS. Part 1. Development background and outline. With the rapid spread of non-face-to-face business and the acceleration of digital transformation, the cloud has emerged as a key infrastructure for quickly and easily utilizing advanced information and communication technologies and services such as artificial intelligence, big data, and the Internet of Things. Based on the strategic judgment that PaaS competitiveness will determine cloud competitiveness in the future, K-PaaS was designed to provide an alternative in the platform competition centered on overseas companies. In 2014, with the support of the Ministry of Science and ICT, K-PaaS research and development began based on the world's #1 e-government platform, the Korea Open Government Standard Framework. Over the next 6 years, K-PaaS underwent development and sophistication stages, and the entire source code was opened, so that any domestic public or private company can use K-PaaS for free from platform dependencies. By providing an environment where cloud software and services can be developed, operated, and used quickly and easily, K-PaaS will evolve from an infrastructure-centered domestic cloud service to a platform service. Fostering an open-source-based platform ecosystem that is not dependent on a specific company is the biggest purpose of K-PaaS development. K-PaaS is a PaaS service that is middleware in nature. It provides a stable and proven platform for cloud service providers, an easy, convenient, and familiar development operating environment for application developers, and a flexible and portable usage environment and rich cloud application tools for cloud service users. When developers configure a work environment such as development server to develop software, K-PaaS automates the installation and configuration of standardized software such as servers, storage, networks, frameworks, middleware, and operating systems required for configuration and development. As a result, developers have the advantage of developing and testing code without any extra work and can focus on their development tasks. The ES supported by K-PaaS can be categorized as shown in the textbook. Private clouds are OpenStack, VMware, vSphere, etc., and public clouds are AWS, MS Azure, Google Cloud Platform, etc. There are 8 characteristics that can summarize K-PaaS. First, breaking away from infrastructure dependency. It supports 10 different types of infrastructure EAs. Second, support for domestic software services. Promotes the deployment and spread of excellent domestic solutions. Third, rich development and operation environment. We support development environments and DevOps tools. Fourth, Cloud Foundry and Kubernetes dual integration environment. Supports optional integrated development of Cloud Foundry and Kubernetes. Fifth, enhanced security. We check for security vulnerabilities, take action, and reflect them in GitHub. 6. Marketplace. We support usage-based metering, purchasing management, product catalogs, and more. 7th. Integrated monitoring. Integrated monitoring from infrastructure to application services. 8th. Autoscale and failover. Automatically scale VMs and containers based on usage, and recover from failures. Let's take a look at what you can expect from using K-PaaS. First, reduce IT costs by maximizing the utilization of hardware resources based on containers. Second, rapid development and testing of application software by automating the installation and configuration of standardized hardware and software in minutes. Third, stable system operation while maintaining service levels with a small number of system operators. Fourth, automatically ensure high availability at the hardware and software level without the need for separate solutions to ensure high availability. Fifth, enable standardized application software management through various ES support and containers. Introduction to the authentication and licenses that K-PaaS has obtained. We have obtained Kubernetes certification from CNCF, the international certification body for Kubernetes, and adopted the Apache license version 2.0. However, for external open source used within K-PaaS, we maintain the license policy of the original open source. K-PaaS has released new version almost every year since its first public release in 2014, with the most recent, version 6.5 of Farfalle, released on 2023. The table in the textbook shows the detailed features of K-PaaS by version. The table below shows the features of the first version and the Linguini version. The Pen version 3.0, released in 2017, and Rotel version 4.0, updated in 2018. This are the feature of 5.0 Ravioli, released in 2019, and Semini, version 5.5 of K-PaaS, released in 2021. The features of Anelli 6.0, released on 2022. Finally, there's version 6.5 of Farfalle, which is the most recent version in 2023. We'll take a closer look at the key features of each version of Farfalle in Part 2. K-PaaS, which has been developed and upgraded, is currently being utilized by major private companies, including government and public organizations. The contents of this book are examples of platform construction based on K-PaaS. Part 2. Architecture. The image in the textbook is an overall configuration diagram of K-PaaS. K-PaaS automates the installation and configuration of standardized software, such as servers, storage, networks, frameworks, middleware, and operating systems required for configuration and development when developers set up a work environment, such as a development server to develop software. Let's take a closer look at the core features of K-PaaS. The container platform and the application platform. First, this is how the container platform works. It consists of a Kubernetes cluster and the storage servers needed for operation, and deploys containerized applications based on a description. The deployed applications can then deploy optimal nodes and maintain the state defined in the description. The next is the configuration diagram of an application platform. At the bottom are the infrastructure, host operating system, and hypervisor, which are responsible for configuring the virtualization on the physical server. Above that, inside the orange border, is the engine area of the Cloud Foundry. Outside the border, the VM Guest OS is a separate VM that manages the hypervisor and the VMs in the Cloud Foundry engine. The VM Guest OSs in the orange border provide the application platform, using the Cloud Foundry engine. On top of that, Guard and Runc supports the deployment of applications in the form of containers, and it provides the framework, runtime, that actually runs them, which can be stored and used across multiple VMs. So that's how the PaaS is running, with applications running on top of those containers. K-PaaS Sidecar Configuration Diagram. Sidecar is an open project based on Cloud Foundry for Kubernetes to combine the benefits of an application platform on top of Kubernetes. Sidecar is almost like an application platform component, but it includes Kubernetes and various cloud-native, open-source projects. The functions and roles of each component that make up the architecture of K-PaaS are as shown in the textbook, and the components can be roughly divided into four. First, the container platform, application platform, and sidecar provide services for developing and deploying applications and managing their execution operations. This service provides containers for application execution by supporting various language packs such as Java, PHP, Ruby, and Go, and supports the use of PaaS internal and external services such as databases and message queues in conjunction with the service environment. It provides account registration and access authentication to use PaaS features, permission management to perform control over APIs that can be used after authentication or resources that can be controlled, and access management services to access applications. Second, service provides an external service broker for interfacing with various external backend platform services when running applications, and an API management service for API management and interfacing. Third, operational tools define infrastructure, control, and integration, and management services for the application platform. It provides operational dashboards for administrators and individual tenant and monitoring dashboards, as well as logging and metering plug-in services. Fourth, development tools provide a self-service portal and development tools for developing, deploying, and operating applications utilizing the PaaS platform. Part 3. Characteristics and core functions of 6.5 version. This introduction to K-PaaS version 6.5, Farfalle, which was released in 2023. Version 6.5 utilizes 119 open sources applied to K-PaaS by applying and verifying the latest patches for stabilization, including Kubernetes and Cloud Foundry. Among them, the container platform based on Kubernetes and the application platform based on Cloud Foundry are undergoing regular security checks for stabilization, and security vulnerabilities are patched and updates are applied accordingly. Next is the characteristics of the Farfalle version. First, we've upgraded the existing management dashboard by adding multi-cluster functionality, and added the ability to automate multi-cluster creation through the dashboard. Second, the official version of Sidecar, which was announced at last year's pub event, has been released. This year, we released the user operator portal for user convenience after releasing the beta version. Third, lightweight and flexible log monitoring. With lightweight and flexible log monitoring, we lighten the monitoring environment by using FluentD. Fourth, modernized and stabilized security. We have completed security vulnerability measures and applied the latest patches. Let's take a closer look at the characteristics. First, multi-cluster support for container platforms. Supports multi-cluster management and cluster auto-creation. While traditional container platforms deploy and manage a single cluster of Kubernetes, Farfalle supports the ability to upgrade the cluster management dashboard and auto-deploy clusters through a single UI. Second, official version of Sidecar revealed. The application platform upgraded and patched 10 existing services, added user domain certificates, reorganized the logging service, introduced FluentD, and upgraded the builder and language functions as a deployment pipeline service. Just as the application platform, platform-based services, and user portal operator portal organically support user application development and operation, Sidecar in a Kubernetes cluster environment also release services and portals to enable user application development and operation. Both the application platform and Sidecar can be targeted and operated as user and operator portals. Third, lightweight and flexible FluentD-based log monitoring support. We changed the log monitoring architecture to FluentD to lighten the log monitoring component. FluentD is used by more than 5,000 data-driven companies and can collect information from a large number of log data, with a small memory space leads to saving memory. Fourth, security vulnerability measures and latest patch application verification. K-PaaS regularly measures and reflects all CVEs and CCEs according to security vulnerability checks. In addition, we strengthen security by applying and verifying the latest patches for errors and performance improvements. Part 4. Introducing Open Cloud Platform Center. Main role of the Open Cloud Platform Center are the following. First, the application platform supports AP upgrades based on Cloud Foundry, AP lightweighting, AP portal, AP compatibility. Next, the container platform section is responsible for research and development of K-PaaS based on Kubernetes. Kubernetes utilization. Supports K-PaaS service research and development. To be followed by technical support section. Supports K-PaaS installation and technical support. Professional training and customized training. Portal operation management. CVE, CCE checks and measures. Compatibility and scalability checks. Finally, the OPA Secretariat supports the operation of the Steering Committee, Technical Subcommittee, Human Resource Development Subcommittee, Standardization Subcommittee, and Policy Promotion Subcommittee to create a self-sustaining ecosystem of private-centric open cloud platforms in Korea. The illustration in the textbook shows the roles of the Open Cloud Platform Center. The center was established on August 12, 2020 as a dedicated organization to fulfill these roles. Policy support. It is composed of NIA personnel for global dissemination, etc., and external private experts for R&D, technical support and more. Next, let's take a look at the details of what the Open Cloud Platform Center is working on. Each part works together to help upgrade, maintain, and manage K-PaaS and activate the K-PaaS ecosystem in the center. Specialized technical support for the application and spread of K-PaaS. K-PaaS experts, company fostering activities. For more information about the Open Cloud Platform Center and K-PaaS, you can visit the K-PaaS portal. The portal contains a variety of information, including English guides, training, technical support, and more. You can also find a guide on how to operate K-PaaS in the portal menu. This concludes Section 4, Understanding K-PaaS, and Day 1 of training. In the next chapter, Day 2, we will learn about the K-PaaS container platform. Good job, everyone.